How's it going, ladies and gentlemen? Mr. Donnie here again, looking at 20.1 problems. All right, so the first question is, what is the oxidation number of sulfur in the HSO4 minus ion? Well, first thing to look at is that minus. It tells us the whole charge of that whole thing has to be -1. Well, we look up what's the charge of hydrogen. Since it's listed first, it's going to be +1. So we know that there's a +1. S we don't know. And oxygen, each oxygen is -2 because that's the only possible charge for oxygen. And there's 4 of them, so that tells us there's a -8. So we know that +1 plus sulfur minus 8 has to equal -1. So basically 1 plus sulfur has to equal +7. So what's that tell us sulfur has to equal? Sulfur equals +6. Right? It's just figure out what the charge is. 2. Which element is oxidized in the reaction below? So in order to do this, you got to look at the charge for everything. Iodine's already given to you as -1. Again, we have to figure out Mn's charge, which would be +7. Hydrogen is plus, I give it to you. I2, the charge of iodine there is 0. Here, Mn's got to be +4. And hydrogen's +1, and the oxygen's -2. So oxidize. Remember, oxidation is losing electrons, so the charge goes up. So what's being oxidized here? The thing whose charge went up. And it would be the iodine. Right? It went from -1 to 0. So the charge went up or became more positive. So the iodide was oxidized. Just to continue reviewing, rake, reduction is gaining electrons, and the charge would go down because it's gaining negative electrons. And number 3, which one of the following reactions is a redox reaction? Redox reaction, you have reduction and oxidation, so you have charges that are changing. So you want to go through these problems and see, hey, where is there an exchange of electrons? Where are we going to have the charges change? And you just kind of assign the charges. You go through and you see what each thing is. And you can see that the charges for none of them change at all, actually. Right? All of these, the charges remain the same, so it would have to be choice D. None of the above is a redox reaction because none of the charges change. All right, number 4, what is the oxidizing agent? All right, so the oxidizing agent gets reduced. Right? So the riddle I think of is what gets wetter as it dries? It's a towel. A towel gets wetter as it dries. A towel is a drying agent, it gets wet. An oxidizing agent gets reduced. So you're going to figure out, well, what gets reduced? In order to do that, you got to go and assign charges. So we know that each chromium here is +6, sulfur is +2, oxygen's -2. Here, now this would probably throw you off a little bit, but let's ignore it for now. In this problem, what gets reduced, we've already answered. Chromium goes from +6 to +3. So the thing that gets reduced was the chromium 207 -2. That thing got reduced. All right, same reaction, but what is the reducing agent? So it is the thing that gets oxidized. All right, what gets oxidized? Well, you can do a process of elimination. We already know that that got reduced. And H plus stays H plus on both sides, so it can't be that. So process of elimination would tell us that it would be the S2O3 because it became S4O6. Now the charge on this is weird. We're not really going to get into why it's so weird, but you would have got an average of each one of those being like 2.5, which isn't, accurate. There's 2 of them that are 0 charge, and then 2 of them that are +5 charge. And we're not going to get into anything that too crazy, but you should have been able to figure out that it was this thing by the process of elimination. All right, and 6. What is the oxidation number of chromium and Cr2O7 -2 ion? So again, you know that the whole thing has to be -2. You got 7 oxygens, right? Each with a -2 charge. And you got 2 chromiums with whatever chromium's charge is. So we do the math. So 2 chromiums -14 has to equal -2. So we know that 2 chromiums has to equal 12. So you know that chromium equals 6. Just that math right there. All right, cool. That's it for that part.